Welcome to another video. I'll be solving the 1988 AP Calc AB exam. I'll be starting to solve it, okay? And I'll give my usual disclaimer as to please check whether the content in this exam is relevant to what's taught in AP Calc AB as of whenever you're watching this video. And yeah, so let's just begin, okay? And actually, for this exam, I believe the College Board has released the distribution for each problem, like how many people got it right, and all that. So I might say it for some problems for what I find interesting, okay? So like for this first problem, 88% of the people got it correct, okay? Let's see. Let's begin. Y is x squared e to x, dy dx equal to what? This is just product rule, okay? First, d second plus second, d first. That's my chance. So first, d second, so x squared, derivative second, derivative e to x is just e to x plus second, d first, derivative of x squared is just 2x. So which one is that? That is, doesn't match any of the problems. So maybe let's factor out the e to the x. E to the x times x squared plus 2x. We can even factor out x. It'll be x e to the x times x plus 2. Okay, so that's C. 88% of people got that right. All right, next, domain of this function. Well, we know that, first of all, x cannot equal to 3. Okay. Now, we also know that what's under the square root has to be greater than or equal to 0. Okay, or x plus 2, x minus 2 has to be greater than or equal to 0. Okay, so we'll do our usual test. Minus 2 to 2, so I'm just going to squeeze it there. When x is a huge negative number, what's the sign? Is it positive or negative? Huge negative number plus 2, that's negative. Huge negative number minus 2, that's negative. Two negatives make a positive. Well, if you plug in some number between negative 2 and 2, like 0, this would be positive, this would be negative, so the sign would be negative, okay? And then finally, we plug in a huge positive number, they would both be positive, so the sign is positive. So we know that x could be less than negative 2, and it could be inclusive, and x could be greater than or equal to 2, but x cannot equal to negative 3. So I believe 2 looks like is D, and that's correct. Only 60% of the people got this right. Okay, most people, the second most popular answer, 21% of the people picked this one, but they missed the point that what's under the radical has to be, the square root has to be greater than or equal to 0, okay? Next, particle with velocity at any time t is given by v of t as e to t, moves in a straight line. How far does the particle move from t is 0 to t is 2? Velocity is always positive, so we don't have to worry about it moving backwards, okay? So that's just the integral from 0 to 2 of e to the t dt, which is just e to the t, evaluate from 0 to 2, which is e squared minus 1. 3 is A. 83% people got that right. Graph of this is concave down for all values of x such that what? Concave down, concavity, that should signal second derivative. So let me do it here. Y prime, let's find that first. It would be, well, we can rewrite y as minus 5, x minus 2 to the negative 1 power. Okay? So we can just use the power rule and chain rule. Okay, so it'll be 5 times x minus 2 to the negative 2 power times derivative inside, that's just 1. Okay, y double prime would be negative 10 x minus 2 to the negative 3 power. So that's minus 10 over x minus 2 cubed. Okay, so what's the critical point here? It's just when this is undefined. So when x is 2, so let's just check. Okay, when we plug in a huge positive number, this would be positive. Negative divided by positive, it's negative. Plug in a huge negative number, so negative number minus negative, minus 2, that's still negative. Negative cubed would be negative. Negative 10 divided by a negative number, that's positive. So we know that it's concave down when x is greater than 2. 4 is E. Only 60% of the people got that right. All right, next one, almost 90% of the people got it right. Because integral of secant squared, that's easy. That's just tangent x plus c. Okay, let's move on. I can flip the page. Okay. Y is ln x over x, then dy dx is equal to what? Here we can either use quotient rule or the product rule. We can rewrite y as 1 over x times ln x to use the product rule, which is first d second plus second d first. So first d second derivative ln x is just 1 over x, plus second d first derivative of 1 over x is minus 1 over x squared. So this is the same thing as 1 over x squared minus ln x over x squared, which we can combine the fractions to d. 6d, yes. 83% of the people got that right. Integral of x dx over 3x squared plus 5, we can let u be 3x squared plus 5. Du would be what? 6x dx. So our integral becomes x dx, that's du over 6. So a sixth du over square root u. That's equal to a sixth times, what would that be? 2 square root u plus c, because this is u to the negative half. We just did a power rule. So it'll be 2 root u plus c. So this is what? A third square root of what's u? 3x squared plus 5 plus c. That is D. Yes, 79% of the people got that right. Okay. Only 60% of the people got this right. Let's see. Graph of y is f of x is shown in the figure above, on which of the following intervals are dy dx greater than 0 and second derivative is less than 0. So this is f. When dy dx is greater than 0, that means f is increasing. Second derivative is negative, that means f is concave down. Okay? So when is it concave down but f is increasing? This is concave up, so we can eliminate this region already. This is concave down, f is increasing, so this seems good. This is concave down, f is decreasing. So it's only from B to C. So 2 only, 8B, yes. I don't know why only 60% of the people got that right. It was quite easy. Okay. Let's move on. X plus 2y minus y squared is equal to 2. Then at the point 1, 1, dy dx is equal to what? Here we need to implicitly differentiate. Okay? Then how do we do that? We differentiate both sides, so it'll be derivative of x is 1. Here we need the product rule. First d second plus second d first. This is my third time saying that in this video already. First, d second derivative of y is just dy dx. Plus second, d first derivative of 2x is just 2. Derivative of y squared is 2y dy dx. Derivative of 2 is just 0. Okay? So we solve for dy dx. So let's move this 1 and this 2y to the other side. So 2x dy dx minus 2y dy dx is equal to negative 2y minus 1. So dy dx is equal to negative 2y minus 1 over 2x minus 2y. Okay? So we evaluate this at the point 1, 1. That's what the question asks. So this is what? Negative 2 minus 1 over 2 minus 2. Oh, we are dividing by 0. The derivative does not exist. 80% of people got that right. Okay. 10, integral from 0 to k, 2kx minus x squared dx is 18. Then k is equal to what? Okay. Let me like this. Okay. So we have to assume k is a constant. So let's just do the power rule. Let's see what happens. Here would be kx squared minus x cubed over 3. We evaluate from 0 to k. Okay, this is equal to 18. Okay, so we have k cubed minus k cubed over 3. When x is 0, they're both 0, so we don't have to worry about the lower limit, is 18. Okay, so this is 2/3 k cubed is 18. Okay, k cubed is, what is that? 9 times 3 is 27. K is equal to 3. Can you see? Good. Oh, 80% of people got that right. Good. Equation of the line tangent to the graph of f is x times 1 minus 2x cubed at the point 1, negative 1 is equation of the tangent line. We need the slope of the tangent line. That's the derivative. So let's find the derivative of this guy. And again, we need product rule and the chain rule here. So f prime, product rule first, d second plus second, d first. First, d second, we need to use first the power rule and then the chain rule. Okay? That's that, plus second, d first derivative of x is just 1. Okay? So we evaluate this at x is equal to 1, because that's the x coordinate of that point. So that's equal to what? It'll be 1 times 3 times, if 1 is here, that's negative 1 squared. We just write that out, minus 2, plus, this is what? Also minus 1, but cubed. Okay, so this would go away. This would be minus 6 minus 1, which is negative 7. So this is slope of the tangent line. We have a point, we have a slope. We can use point slope for it. Y minus negative 1 or plus 1 is negative 7 times x minus 1. Or y is minus 7x plus 7 minus 1. Y is minus 7x plus 6. 11 should be A. Okay? I don't know if the piece of paper got cut off. Hopefully it did not, but here it is once again. You can pause the video if you need to. And interestingly, only 61% of the people got that right. I don't know. What was the low? Was it this part that was difficult? I don't know. Okay. F of x is sine x. F prime of pi over 3 is, well, what's f prime of x? F prime is just cosine. Value at x is equal to pi over 3. So it's cosine of pi over 3, which is half. 12 should be B. Oh, what? Only 76% of the people got this right? I don't understand why. That was so easy. Okay. If the function f has a continuous derivative on the interval 0 to c, the integral from 0 to c f prime of x dx is what? Okay? This is just saying has a continuous derivative. It's just saying this is differentiable, so that we can find the antiderivative of f prime, which is f. So this is just fundamental theorem calculus, I believe. So it'll be f of c minus f of 0. So I believe 13 is A. Only 70% of people got that right. Okay, so this, you had to realize that this just means that if the derivative exists, f has a continuous derivative, so that's this guy, then we can find the antiderivative, which is this fundamental theorem calculus over here, okay? Over here, how do we solve this integral? Well, I can immediately see we can let u be 1 plus sine theta, okay? So du would be cosine theta d theta, okay? Then we change the limits of integration. When theta is 0, u is 1. When theta is pi over 2, u is 2. Okay? So it would be what? Cosine theta d theta, that's just du. And then over square root u. So this is just 2 square root u, evaluate from 1 to 2, which is 2 times root 2 minus 1. Okay? So that 14 is D? Yes, only 67% of people got that right. Okay. F of x is square root of 2x. Then f prime of 2 is what? We need to chain rule. So f prime would be, this is the same thing as 2x to the half, if you like that better. I know it as 1 over 2 root of 2x times derivative of the inside. That is 2. So this will cancel, so we're left with 1 over root of 2x. Okay, and then we evaluate this at x is equal to 2. So that's 1 over root 4, which is half. 15b. Only 65% of people got that right. Probably you have to remember to chain rule. Our particle moves along the x-axis so that anytime t greater than or equal to 0, its position is given by this. For what values of t is the particle at rest? Particle is at rest when velocity is 0, which is x prime of t. Okay, so let's find x prime. We just used the power rule. X prime is 3t squared minus 6t minus 9. We set it equal to 0. We can factor out a 3, so it'll become t squared minus 2t minus 3 is equal to 0. 3 times t minus 3, t plus 1 is equal to 0. So t is minus 1 and 3. When t is negative 1 or t is 3, then the particle is at rest. But t is greater than or equal to 0, so we only take this answer, which is C, 16C. Yes, only about 3/4 of the people got this right. All right, this one, there's multiple ways you can do this. You could expand it out, or you could do a substitution. Okay, I think the substitution way would be easier because when you do from, actually, well, there's a limit of 0, so it shouldn't be hard, but let me just do a substitution. U is 3x minus 2. Du would be 3 dx. So our integral becomes, well, when x is 0, u is negative 2. When x is 1, u is 1. So it would be u squared du, du over 3 is dx, so a third du. Okay, so this is a third times u cubed over 3, evaluate from negative 2 to 1. That's a ninth of negative 2 cubed. That is negative, we plug in the upper limit first, so that'll just be 1. That's easy. Minus, we plug in the lower limit, that is negative 2 cubed. That would be negative 8. So this is just 9 over 9, which is 1. Did I do this right? I did. 17D. About 72% of people got this right. Okay, so you can do a substitution like I did here, or you could just expand all this out to 9x squared minus 12x plus 4, if I did it in my head correctly. Okay, and then do fundamental theorem calculus, should get the same thing. Okay, if y is 2 cosine of x over 2, then the second derivative is, well, we know y prime would be, well, we need a chain rule. It'll be minus 2 sine of x over 2 times half. So that's this half and this minus 2 we cancel. It'll be minus sine x over 2. So y double prime would be, again, we need a chain rule, so it'll be minus cosine x over 2 times half. 18e. Only 73% of people got this right. So you got to be careful with chain rule. All right, integral from 2 to 3, x over x squared plus 1 dx. We can do another substitution. U is x squared plus 1. Du is 2x dx. So our integral becomes, when x is 2, u is 2 squared plus 1, which is 5. When x is 3, u is 9 plus 1, which is 10. So x dx is du over 2, so half du over u. So this is just half log of u, evaluate from 5 to 10, which is half times log 10 minus log 5. Okay, we don't have any of those, so we have to combine these logs. Okay, this is the same thing as half log of 10 over 5. Okay, which is half ln 2. 19 is B. Only 58% of people got this right, probably because this part shouldn't have been too hard, but you didn't get a matching final answer when we got up to here. So maybe they got stuck. I'm not sure. What's the second most popular answer? E. Oh, they probably subtracted 10 minus 5. They thought that was valid. That's not valid for logs. Okay, properties of logs. You have to know that. All right. Let f be a polynomial function with degree greater than 2. If a not equal to b and f of a is equal to f of b, which is equal to 1, this sounds like one of the theorems. Which of the following must be true for at least one value of x between a and b? This sounds like maybe Rolle's theorem, okay? So let's see. Let's look again. F is a polynomial function with degree greater than 2. We know polynomials are continuous and they're differentiable. Okay? Or I could just set differentiable, which automatically implies it's continuous. Okay? So this is important probably because it's one of the conditions for, like, for example, Rolle's theorem. Okay. Okay, so since f of a is not equal to b, f of a is equal to f of b, which is equal to 1. So if this is a, this is b. Remember, we just said it's continuous and differentiable. Okay? So, and it's with degree greater than 2. Okay? So it eliminates the possibility that it's a straight line. Okay? It's a degree greater than 2. So it will have to since it's continuous and it's with degree greater than 2, it'll have to go like this, or maybe like this, or maybe like this. Okay? Or maybe like this. Okay? So what does Rolle's theorem say? It says that there must be some point in between a and b such that f prime of, let's say that point is c, f prime of c is equal to 0. Okay? So that is choice 2 should be true. What about the others? Okay? If this is equal to 1, well, we don't know if f will ever cross to 0. Okay? It doesn't have to. It could be like this. Or it could be increasing and then decreasing. We don't know. So cannot be that. How about f double prime is equal to 0? Well, can it change concavity? And now that's a good question that I don't know right off the top of my head. Let me think. Does it have to change concavity? Degree greater than 2. It doesn't, because even like, for example, x to the 4th or something like that, it looks kind of like a parabola, right? So, and then it could change concavity later. So it could just be like this, and then take off later, something like that. So it doesn't have to change concavity. Okay, so it's only choice 2. Is that correct? Yes, it is. 41% of people got that right. This was a tough one. I will agree with that. Okay. All right, let's try to do a few more on this page and we'll call it apart. The area of the region enclosed by the graphs y is x and y is x squared minus 3x plus 3 is what? Okay, so we need to find out which one's the upper curve, which one's the lower curve. And we need to find points of intersection, okay? So let's find the points of intersection first. Let's set them equal to each other. Okay, so let's solve for x. So it'll be 0 is x squared minus 4x plus 3. 0 is equal to x minus 3, x minus 1. So x is equal to 1 and 3 are the points of intersection. So it would be 1, 1 and 3, 3. Okay, so this would be the straight line, the linear line, right? We can even extend it more. And how about this? We know it's a parabola. Now we can just even plug in 2. It'll be 4 minus 6 plus 3, which is like 1, if I did it in my head correctly. 4 minus 6, negative 2, plus 3, that's 1, yes. Okay, so it would be something like this. Okay, so this is our region R. We need the area, so it's upper curve minus lower curve. Upper curve is x, minus lower curve is the parabola. And we integrate from, well, we found our points of intersection, 1 to 3. Okay, so this is integral from 1 to 3 of negative x squared. This is plus 3x and another x here, so plus 4x minus 3 dx, okay? So this is just power rule. It'll be minus x cubed over 3 plus 2x minus 2x squared, sorry, minus 3x. Evaluate from 1 to 3. This is going to be tedious math. Minus 27 over 3 plus 18 minus 9 minus the third plus 2 minus 3. But I'm not thinking calculus, this would be 9. This is minus 9, so this actually would go away. So we're left with what? This is 1. So 1 minus the third, that is sorry, this is minus 1. Then this is negative of minus 4/3, which is 4/3. Okay, so it's 21C. Oh, did I get cut off from the video again? My bad. I was just doing the final math over there. Okay, it's 21C. Let me look. It is. Only 63% of the people got this right. So the key point here was we had to find the upper curve and the lower curve and the limits of integration. Limits of integration, we just find the points of intersection. And then once we do that, we get an idea of how the graph looks even. We've found that the upper curve is the linear line, lower curve is the parabola. Okay? If ln x minus ln of 1 over x is equal to 2, then x is equal to what? Okay, this is just algebra. So let me do this, okay? So we can even actually, let me see. We probably have to use properties of logs, is what I'm thinking. Because remember, difference of two logs, so ln x minus ln of 1 over x, that's equal to ln of x over 1 over x. Okay, which is equal to ln of x squared. Okay, so this side's equal to 2. Okay, now this is easy. X squared is e squared. Okay, so x is equal to e plus or minus e. Is it plus or minus? Or is it just e? Well, the only choice, well, it cannot be negative e, sorry, because we can have ln of negative e. So just positive e. So 22 should be c. Yep, only 64% of people got it right. So the key here was properties of logs. F prime is cosine x, g prime is 1 for all x. F of 0 is g of 0, which is equal to 0, then limit as x goes to 0. F of x over g of x is what? Okay, so here, if we just plug in 0, that's obviously 0 over 0, indeterminate, so we gotta do something else. Do you learn L'Hopital's rule here? Would that even help here? It does help because, let me just squeeze it in over here. So I'm assuming you know L'Hopital's rule. So it'll be limit as x goes to 0, since it was 0 over 0, indeterminate quotient. We can differentiate the top, which is f prime, and the bottom, which is g prime. So this is limit as x goes to 0 of, what's f prime? That's just cosine x. What's g prime? That's 1. So this is just 1. 23 is B. Nope, 73% of people. Oh, that's pretty good. Okay, derivative of x to the ln x. This is clearly logarithmic differentiation because it's x to some x power. Okay, so let's let y be x to the ln x. ln y is ln of x to the ln x. Properties of logs, we can move this ln x out to the front because it's a power, times ln x, which is ln x quantity squared. So 1 over y dy dx, we implicitly differentiate, would be 2 ln x times 1 over x. Okay, power rule and then chain rule. So dy dx, which is what we wanted here since we defined y as this, so dy dx is the same as d dx of this guy, is equal to 2 ln x over x times y, which is x to the ln x. Okay? So, oh, did it get cut off again? I really don't know in this video. Here it is on camera. And matching the answers, 24 should be C. Oh, what? People really did not do well on this problem. 21% of people got this right. 42% of people picked this one. Oh, this is clearly, that's what I was saying. You can't just do the power rule. I don't know if I said that earlier. But definitely say in a different video. You cannot just do the power rule here because it's not to some constant power. It's to some function of x power. So you have to do logarithmic differentiation, okay? Cannot simply do power rule here. All right. For all x is greater than 1, oh, this is easy. I already see that's fundamental theorem calculus, okay? F of x is integral from 1 to x, 1 over t dt. F prime of x is what? So over here, we just plug in the limit as the variable of integration. 1 over x times derivative of x, just 1. So 25 is B. 64% of people got this right. The second most popular answer was this one. They probably just integrated, but they thought 1 over t, integral of that is ln, so ln x. No, it's a fundamental theorem calculus, part 1, if your book uses the same convention that I learned it as. Okay? This one is clearly integration by parts. It's interesting how they have it in AB here. So how do we do this? Okay, we let u be x, du is dx, dv cosine x dx, v is sine x. Okay, so this becomes uv minus v du x sine x, evaluate from 0 to pi over 2, minus integral of sine x dx, that's v du, okay, from 0 to pi over 2. So x sine x, we leave that alone. Integral of sine is negative cosine, so it'll be plus cosine x. We evaluate this whole thing from 0 to pi over 2. So when we plug in pi over 2, that'll be pi over 2 times sine pi over 2, which is 1, plus cosine pi over 2 is 0, minus, when x is 0, then it's 0. Cosine of 0 is 1, so it would be pi over 2 minus 1. 26 should be E. 59% of people got this right. This is integration by parts. Okay, and we'll call it a part here, actually. Hopefully this was helpful. Hopefully those stats were interesting, and just me looking at what was the, maybe even the second most popular choice of why people got it wrong was helpful too. Hopefully you don't make the same mistakes. And if you did, that's okay. If you're just practicing, just don't do that next time, obviously, okay? What was I saying? Please like the video if you found it helpful. Please subscribe to the channel to look out for the next part.